All right. So earlier we were talking about physical properties and changes. Remember, physical means that there's no change that could possibly happen to the chemical composition of a substance. All we're doing is looking at it or measuring it. We're not chemically changing anything. There's no chance atoms are going to rearrange themselves. That was physical. This is chemical. And chemicals all about the chemical composition. So, chemical properties are properties that describe the potential chemical changes a substance may undergo. It doesn't mean it's going to. Some chemical properties are really, really boring, like the fact that the helium doesn't really do anything interesting inside your body. As long as you also are breathing in oxygen, you can't deprive yourself of oxygen. But helium doesn't react inside your body with anything. It's really boring, but that's a good thing. So sometimes chemical properties are very boring. They don't undergo any changes. And sometimes they're a little more interesting. They may undergo a change. So, this is the big thing here. Chemical properties help us answer the questions: will the atoms in a substance break apart? Will they rearrange themselves? And will they form something new? That is exciting if something different changes. It's not always a good thing, but it's definitely something new. Or it could be kind of boring. Will the atoms in the original substance remain exactly where they are? Meaning, they don't do anything. They don't change. Like the helium, when we breathe it in, it doesn't do anything in our body. Chlorine would. Chlorine would wreak havoc in our body, but not helium, because it has chemical properties of being very stable and unreactive and so forth. So chemical properties help us decide, are the atoms inside the substance that we're testing going to do anything interesting? Are they going to change, or are they going to stay put? So let's look at a few examples. Flammability. Are substances going to burst into flames? Like you might see signs like this on the side of a truck or in the back of a truck that's transporting gases. It's telling you its chemical properties. It's telling you this gas in this tanker is flammable. Or it's telling you that it's non-flammable. So you know what to expect. Are atoms going to rearrange themselves or not? Sometimes it's interesting, sometimes it's boring. If I'm driving on a highway, I really, really, really want it to be boring. All right, ability to rust. Look at these two chains. One of the two chains rusted, and one didn't. Why? Because they have different chemical properties. This one didn't rust for some reason or other. The chemical it's made out of or coated with did not rust, but yet this one did. Another word for that is corrode. Look at this pipe over here. That's corroded. That's chemically changed. Maybe the substance that was flowing inside the piping, maybe the substance in the air around it, caused this stuff to form on that copper piping. That is corroded. So, some substances react. We say they have a high reactivity. Some of them don't. Some of them are radioactive. If they chemically change, then they're radioactive. That's a chemical property. The ability to be toxic or cause problems in a living organism. Chemical stability. Let me see if I can spell it right here. If I store a substance with another substance, is anything going to happen? Are they going to be stable together, or are they going to be unstable and react? So instability. That's another chemical property. So stability, boring, don't change anything. Why? Because they're stable. Or instability, because they're not stable, so they may react together. And then we said reactivity here, but you could talk about reactivity with acids or bases, or reactivity with water, or reactivity with oxygen in the air, reactivity with a whole bunch of different substances. So we can get really specific here, but these are all indications, even the boring things like non-toxic, that's still a chemical property. It still gives you information about whether or not a substance may undergo a change. Now, how do we determine chemical properties? There's only one way. If we want to find out if something has a certain property, the only way to determine that is to give the substances an opportunity, a chance to react, to change, to shuffle atoms around, to break bonds, make new bonds, reassemble atoms, by running a test. So if we don't know things, if we don't know certain chemical properties about stuff, we're going to test it. It's the only way we're going to find out. So here's gold. If I got this gold ring wet with water, is it going to react? Is gold reactive? We're going to test reactivity. So would a gold ring do anything? How about a chunk of sodium? This is sodium metal. It's soft enough that we can cut it like kind of with a butter knife, or here somebody's using a pocket knife and cutting off chunks of this. But if we took this in the shower or did dishes and there was a piece of sodium in our sink, is that a good thing? Would it react? Would it react like gold? Would it react more? Would it react less than gold does? We don't know. We would have to test it. All right, so when we test, and I'll show you the results of that in a second, but when we test for chemical properties, we're either going to get a negative test or a positive test. Now think about getting a strep test. You go to the doctors, or you want to see if you have strep or not. And they swab your throat, they disappear for a little while, and they come back and they tell you you're negative. Negative is actually a good thing because it means you don't have strep. You don't have anything different, new, unique. It's kind of boring. So I'm going to put a little frowny face here. It's boring. Nothing interesting. But if they come back and tell you of a positive result, then that means things changed. It's going to be different. Sometimes that's good, sometimes that's bad. All right, so a negative result. The chemical composition of the substance did not change. It's like you getting your throat swabbed. Nothing changed. You do not have strep. You do not have a new little bacteria growing in your throat. Nothing changed. So the chemical composition did not change despite the fact that it had an opportunity to react and change. You ran the test, you gave it an opportunity, but it did nothing. And this is kind of boring because nothing changed. But that's not always a bad thing. Like if I'm sucking in helium, I don't want anything to change. I want that boring result. If I'm driving behind a big tanker, I want a boring result. Positive results. This is like you having strep. The doctor comes back and says, yep, you're positive for strep. That means the test caused a change. In this case, in your throat, or when we're talking about chemistry, it's a change in the chemical composition. So think about all the modeling that we've been doing. All those atoms that you typically put down and then start moving around. When you move those atoms around and break stuff apart or make new things, you're changing the composition of stuff. So existing bonds are broken. That's like you taking atoms off of a model. Atoms are rearranged. Think about sitting with a pile of atoms in the middle of your desk. What are you going to do with that? You start moving them around. And you make new things, and then you lock them in. You make new bonds. And now we have something entirely new, made from the atoms that we started with. So if you run a test and something interesting happens, think of this as interesting. It's because something changed. The original substance no longer exists. It's been broken apart and the atoms have been used to make something new. And that is interesting. We see a change. It's not always a good change, but it's definitely a change. So let's get back to our gold. You may have had experience with this. If you get gold wet, it does nothing. That's boring, but that's a good thing, especially if that piece of gold is on your finger. You want a negative result. Gold does not react with water, and that's a chemical property. It's a chemical property of gold, non-reactive with water. Now, sodium. Look at this. They're dropping a little tiny piece of sodium in the water. The moment it hits, it explodes. That's a crazy, violent explosion. That is something absolutely new. New things are being made. We'll talk about what they are later on, but definitely that's evidence that things are changing. Sodium does react chemically with water. It is reactive with water. So sometimes it's boring, sometimes it's exciting, but either way, we've got to test it to figure out what kind of chemical property it has. And finally, what's going on if we could zoom in when we see a chemical reaction? Well, the composition is changing. A chemical change and a chemical reaction are synonyms. They mean the same thing. It's basically a change in which the atoms that make up the original reactants, this is what we start with, these are like our ingredients. The original reactants are separated from one another. And you've done this. You've broken atoms apart before, and then you've ended up with a big pile of atoms, individual atoms, and then you've reassembled them to make new things, to make products. So the original reactants are separated from one another and rearranged to form new products. And for a little while, we're stuck with a pile of individual atoms. This is kind of our transition state. They're transitioning from these reactants to new products. So these atoms will be rearranged to become new products. So no longer do we have an N2 and an H2, H2, H2. We don't have that anymore. Break it apart. Got a whole bunch of individual atoms that we reassemble, and we end up with this. NH3 and another NH3. So these NH3s, these new products, are created from the atoms that were originally in the reactants. So if we ever see a positive result, something new is happening, something interesting is happening, it's because this is going on. And we could see it if we had superpowers and could zoom in. We'd see atoms breaking apart, rearranging themselves, and making something new. And we've seen this time and time again this year. We saw it with the sucrose. We saw it with the hexane. We're going to see it with ethanol. We're going to see it over and over and over again.